Hey, Ms. Rivera, I'm really stuck on this one. The problem says the three interior angles of a triangle are the quantity 2x minus 5, the quantity 3x plus 10, and the quantity x plus 15. I've been puzzling over it for a bit, but I just can't figure out how to find x and the three angles.
Hey Cody, I can see why this one might feel a bit tricky, mixing algebra with geometry like this, but it really boils down to recalling one fundamental fact about triangles. Let's break it down together. We're given three expressions for the interior angles: the quantity 2x minus 5, the quantity 3x plus 10, and the quantity x plus 15. Ultimately, we need to find the value of x and then calculate each of those angles. What's the first thing you remember about the sum of the interior angles of any triangle?
I think I remember that the sum of the interior angles of any triangle is always 180 degrees. Is that right? I feel like we went over this a while ago.
You've got it, Cody. That's exactly right. The sum of the interior angles of any triangle, no matter its shape or size, is always 180 degrees. This is a fundamental concept in Euclidean geometry, and it's what's going to unlock this problem for us. How can we use this information, along with the angle expressions you have, to set up an equation?
Okay, so if all three angles add up to 180 degrees, I should add the expressions together and set them equal to 180. So it would be the quantity 2x minus 5 plus the quantity 3x plus 10 plus the quantity x plus 15 equals 180. When I combine the like terms, I think I get 6x plus 30 equals 180. Is that the right way to set it up?
Excellent, Cody. You've perfectly set up the equation by adding all three angle expressions and equating them to 180 degrees. And your step of combining like terms, the quantity 2x plus 3x plus x, and the quantity negative 5 plus 10 plus 15 into 6x plus 20 is also spot on. Now that the equation is simplified to 6x plus 20 equals 180, what's your next move to isolate x?
Okay, so I need to get x by itself. I'll subtract 20 from both sides, so that gives me 6x equals 150. Then I divide 150 by 6 to find x, so I think x equals 25. Does that look right?
That's exactly right, Cody. You've expertly isolated x. Subtracting 20 from both sides gives you 6x equals 150, and then dividing 150 by 6 correctly yields x equals 25. Now that you've found the value of x, how can we use that to find the measure of each of the three interior angles of the triangle?
Okay, so I substitute x equals 25 into each angle expression. For the first angle, the quantity 2 times 25 minus 5 is 45 degrees. For the second one, the quantity 3 times 25 plus 10 should be 80 degrees. And for the last angle, the quantity 25 plus 15 is 40 degrees. So I got 45, 80, and 40. Do those look like the right angles?
You're absolutely on the right track with substituting the value of x back into each expression, Cody. That's exactly how we find the angle measures. However, let's take a quick step back and double-check one calculation from before. When we had 6x equals 160, what did you get when you divided 160 by 6? Let's make sure our x value is precise before we calculate the angles.
Oh, right. I must have done the subtraction wrong before. Okay, so if it's 6x equals 160, then to find x, I need to divide 160 by 6. Let me try that again. I'm getting 26.5. Is that what x should be now?
You're very close with that division, Cody. Dividing 160 by 6 does give us a decimal, but 26.5 isn't quite the exact value. Try performing that division again, maybe to 2 decimal places, to make sure we have the most accurate x before we move on. What do you get when you calculate 160 divided by 6?
Okay, let me try that division again, making sure to be more precise. So, 160 divided by 6, that would be 26.666, and it keeps going. If I round it to 2 decimal places, I get 26.67. Is that the accurate x value we should use?
Yes, Cody, 26.67 is an excellent approximation for x rounded to 2 decimal places. It's important to be precise here because even small rounding differences can affect our final angle measures. Now that we have a precise value for x, which is 26.67, how would you go about finding the measure of each of the three angles?
Okay, so I'll plug in x equals 26.67 for each angle. For the first angle, 2 times 26.67 minus 5 gives me 48.34 degrees. For the second angle, 3 times 26.67 plus 10, I think that's 89.01 degrees. And for the third angle, 26.67 plus 15 is 41.67 degrees. So 48.34, 89.01, and 41.67.
You've done a great job substituting x into the expressions for the first and third angles, Cody. Your calculations for 2 times 26.67 minus 5 equals 48.34 degrees and 26.67 plus 15 equals 41.67 degrees are both correct. However, let's take another look at the calculation for the second angle. What do you get when you carefully calculate 3 times 26.67 plus 10?
You're right. Let me recheck that second angle carefully. So 3 times 26.67 is 80.01, and then adding 10 to that gives me 90.01 degrees. Is 90.01 degrees the correct measure for that second angle?
Yes, Cody, 90.01 degrees is correct for that second angle. You've successfully calculated all three angles using the precise value of x. So our three angles are 48.34 degrees, 90.01 degrees, and 41.67 degrees. What's one final way we can check our work to make sure these angles truly belong to a triangle?
Oh, right. We should add them all up to see if they equal 180 degrees, since that's what we started with. So 48.34 plus 90.01 plus 41.67. That adds up to exactly 180.02 degrees. That's pretty close to 180.
That's a perfect final check, Cody. Adding the angles together and seeing that they sum to 180.02 degrees confirms that our calculations are correct, especially considering we rounded x to 2 decimal places. If we hadn't rounded x, the sum would be exactly 180 degrees. You've successfully found both x and all three angles. Congratulations, you've solved the problem.
Thanks so much, Miss Rivera. I feel really good about this now. It was tricky remembering to be super precise with that x value, but adding all the angles back up to 180 degrees at the end really helped make sure it was right. I appreciate you guiding me through it.